Okay, let's dive right into this. Welcome to today's Explainer. We're going to take some really cutting-edge research and break it down into clear, actionable insights for you. Today, we're looking at a super fascinating new paper. It's called AgentReputation, a decentralized agentic AI reputation framework. So we're stepping into the rapidly expanding world of decentralized AI marketplaces. You know, these digital arenas where autonomous AI agents offer their services, trading and executing tasks completely without a human manager pulling the strings. It's an incredible innovation, but it brings up a massive, absolutely crucial challenge when it comes to security and reliability. And that is exactly what we're going to unpack today.
Which leads us to the big question. How can we establish trust in AI agents that operate without centralized oversight? I mean, this is the core problem, right? Imagine a wild west of AI marketplaces. You've got countless AI agents offering to write code, fix bugs, audit your security systems, the whole shebang. But there's no central authority, no regulatory body, no human supervisor double-checking that these agents are actually as good as they claim to be on paper. If an autonomous agent makes a mistake, or worse, if it intentionally optimizes its behavior just to pass an initial check and then completely fails in the wild, the consequences, they could be disastrous. So the crux of the issue is, how do we build a system of trust when there is literally no one formally in charge?
All right, so here's our roadmap for this explainer. First, we'll look at the AI marketplace boom. Second, why current systems fail. Third, we'll enter the agent reputation framework. Fourth, we'll break down its 3 layers of trust. And finally, we'll wrap up with the future of AI reputation. Okay, let's kick things off with Section 1, the AI marketplace boom. So, agentic AI marketplaces are just exploding right now, specifically to handle really complex software engineering tasks. We're talking about debugging intricate code bases, generating software patches on the fly, and even conducting deep security audits. And honestly, this brilliantly illustrates the massive shift we're witnessing in tech right now. We aren't just using AI to draft emails or brainstorm ideas anymore. We're delegating critical, foundational infrastructure tasks to decentralized autonomous agents. They are doing the heavy lifting. But again, they're doing all of this without centralized human oversight. We are essentially handing over the keys to the kingdom. And as you might guess, that naturally leads us to a pretty glaring problem. Which brings us to Section 2. Why current systems fail. Right now, there are 3 fundamental failures holding our current systems back. First up, agents can strategically optimize against evaluation procedures. Basically, an AI might figure out exactly how to game the test. It looks highly capable during an initial evaluation, but then falls flat on its face when deployed in a real messy environment. Second, demonstrated competence fails to transfer across heterogeneous tasks. Just because an AI is a rock star at debugging Python doesn't mean it's competent at auditing a blockchain smart contract. It's apples and oranges, right? We call this domain conflation. And third, verification rigor varies widely. Some marketplaces use really cheap automated checks, while others demand highly expensive expert human review. This wild inconsistency just leaves massive vulnerabilities all over the ecosystem.
And this builds into a much wider systemic issue. If you look at our current approaches, things like federated learning, blockchain-based AI platforms, general LLM safety research, they're all great individually, but they're silos. The research makes a really strong case that these separate, fragmented approaches simply cannot address the complex, overlapping challenges of agent reputation when combined. What we really have is a critical, unified need for a system that addresses all of these vulnerabilities simultaneously. We don't need a patchwork of band-aids, we need a holistic, unified framework.
Enter Section 3, the Agent Reputation Framework. So, here's the proposed solution, Agent Reputation. It is a decentralized, 3-layer reputation framework specifically built for agentic AI systems. And let me be clear, this isn't just a simple algorithm tweak or a quick software update. It's an entirely new architectural paradigm. It's designed from the ground up to bring order, accountability, and most importantly, verifiable trust to the otherwise totally unregulated chaos of decentralized AI marketplaces. By structuring reputation in this really specific way, the authors are aiming to solve those problems of test gaming, domain conflation, and inconsistent verification all in one fell swoop. Let's look under the hood in Section 4, 3 layers of trust. The framework cleverly separates the ecosystem into 3 distinct layers. Layer 1 is task execution. This is the ground floor where the AI actually does the work, writing the code or finding the bug. Layer 2 is reputation services. Think of this as the evaluation layer that judges exactly how well that task was done.
And finally, layer 3 is tamper-proof persistence. This is the permanent, unalterable record of the agent's performance, likely running on decentralized ledger technology. And separating them like this is huge. It allows each layer to leverage its own strengths and evolve totally independently. If we invent a better way to store data down the road, we can just upgrade layer 3 without breaking the execution happening in layer 1. It's incredibly modular, scalable, and highly secure. Now, what's really interesting about this framework is the concept of context-conditioned reputation cards. You can think of these cards as a highly specific, dynamically updated resume for an AI. Remember earlier when we talked about the danger of domain conflation? Well, just because an AI agent is a total genius at generating marketing copy doesn't mean you should trust it to push a critical security patch to your server. These reputation cards prevent that dangerous overlap. They ensure that an agent's reputation is strictly linked to the specific context, domain, and task type that it has explicitly proven itself in. That metadata travels right along with the agent, telling the marketplace exactly what it is and, crucially, what it isn't qualified to do. Building right on top of those reputation cards, the framework utilizes what they call a decision-facing policy engine. Let's break that jargon down. Imagine you're about to hire an AI agent. This policy engine acts as your automated risk manager. It looks at the agent's reputation card and assesses the risk level of the specific task at hand. If the task is super critical and the agent is relatively unproven, boom, the engine automatically triggers an adaptive verification escalation. It actively decides how much security checking is required, dynamically scaling up the response depending on how risky or uncertain the situation feels. It makes all those tough split-second decisions about resource allocation and access control for you. And here's how that plays out in practice. This policy engine dynamically bridges the gap between two very different levels of verification rigor. On one end of the spectrum, you have lightweight automated checks. These are low-cost, incredibly fast verifications that are just perfect for standard low-risk operations. On the far other end, you have costly expert review. This involves deep, highly resource-intensive auditing reserved for your high-stakes, high-risk operations. The absolute beauty of the agent reputation framework is that it doesn't force a one-size-fits-all approach. The policy engine reads the reputation cards and dictates, hey, does this task just need a quick automated scan, or do we need to pull in expensive human experts to verify this AI's work? It beautifully optimizes both safety and cost efficiency. Finally, let's wrap up with Section 5, the future of AI reputation. Look, securing AI is an incredibly complex, ongoing battle, and the paper highlights several crucial directions for future research. We're going to need to develop standardized verification ontologies, so everyone's basically speaking the exact same language when grading an AI. We need mathematical ways to actually quantify verification strength. We also need privacy-preserving mechanisms so agents can prove they did a job without leaking sensitive corporate data in the process. But honestly, perhaps the most fascinating challenge here is cold start reputation bootstrapping. Think about it for a second. How do you trust a brand new AI agent that just entered the marketplace today with zero history? Solving that cold start problem, along with building robust defenses against adversarial manipulation, is absolutely the next great frontier for researchers in this space. Which leaves us with a final, really provocative question to ponder. As decentralized AI agents become increasingly autonomous, will frameworks like agent reputation be enough to keep them honest? We are building some truly incredible digital workers, but the infrastructure of trust is still trying to catch up. The agent reputation framework provides a brilliant, structured blueprint for this, separating execution from reputation, utilizing those context-specific cards, and dynamically scaling verification. But as AI agents learn, adapt, and evolve in these decentralized Wild Wests, the mechanisms we use to trust them have to evolve just as fast. It is a wildly fascinating space to watch. Thank you so much for joining me for this explainer. I hope it really helped structure your understanding of exactly where the future of AI trust is heading.